My name is Hop Fan. I'm a lead developer experience working for Kahoot.ai. Spent 5 years at Microsoft. Microsoft Purview, if you heard of the security teams that where I used to be. And today I'm gonna go over the best practices of building reliable AI agents on local machine as well in production. So can I get a raise of hand of who here build AI agent, like LLM AI agents? Okay, just keep your hands up, like who here actually do observability on your LLM agents? Nobody. That's my guess. So I'm gonna go over the topic of how to do AI observability, but in a different angle. Not in terms of like train your model and refine your model, but in terms of how to actually use it to generate code and make sure it's reliable, and how to use that in your CDCI pipeline in production. So if you go to the portal.okaho.co, you can actually run through the same demo that I'm gonna go through. So what is an AI agent? So let's see that in action really quick. If for those of you don't know what it is. So this is an AI agent. Okay, so you have an agent, tell the tool to do something, and guess what? The wrong tool being called. Look, this is the tool right here. This guy actually answer is done, but actually the match is still there, right? So it's like a very simple example of where you actually talk to a bot and the bot say, I'm done, but actually nothing happened. So I'm gonna go over the slides really quick on the agentic design patterns. So typically you have a user ask a question or ask the request to do a task. The agents decide what to do, basically call the LLM to do a breakdown of the task into tool calls, and the tool actually decide on the execution of the task, right? This is one example of Google ADK. So, for those of you who are familiar with this, or if not, it's basically a declaration of the agent with prompts, some context, some memories, and what the LLM to use. And then you have the tool, the list of tools over here. And the tool actually do the actual implementation of the task, right? So the reason I'm trying to bring this one out is because later on we're gonna go over one example test case where we're gonna do it an assert on all of this and make sure things get executed correctly. So the reason LLM agent or AI agent is hard to debug is because they are not deterministic. They behave differently every time you run it, and it's very hard to explain. You can wake up 7 o'clock in the morning and do things differently from the one that you run 9 o'clock last night. And it's just like Alvin, right? So the chipmunks. It's very hard to know what the chipmunk gonna hop next and what it's gonna do, and it's gonna surprise you all the time, and you have no idea where the footprint is. So we have our company actually sponsor for the project Monocle. It's actually under the Linux Foundation, AI and data. And Monocle is an extension of OpenTelemetry. And if you know OpenTelemetry, it has a very specific format that we work with them. And you can use Monocle to ingest OpenTelemetry information as well as sending to any OpenTelemetry compatible data source.
Thank you.
So what is so special about Monocle? It's high performance. So typically when you run OpenTelemetry, you have to export it to somewhere, right? A destination in the cloud or like a Docker container. What we do specifically here that's different is that we have the traces actually output to a local machine, and you can use that information to train the LLM to go through the iteration and make sure it do things correctly in the next time. We have a lot of support framework being supported right now, and we're actually looking for more contributors. So if you go to monocle2ai.org, you can see more information about documentation that we have, as well as the link to the GitHub repo. So what the challenge on working with the agent, because they are a bigger black box, and it's hard to understand and inspect the prompts and the response. And the context switching between your IDE and a separate tool, let's say you have like Dynatrace, Datadogs, Langfuse. I mean, we work with a bunch of them as well as a partner. It's very hard to switch the context. And what we actually have is an integrated tray visualization inside of your IDE. And this is actually free. So you can install this in your GitHub, in your VS Code or Cursor. And when you run through the agent flow, it's actually spit out the trace locally, and you can actually view it, visualize it, and ask questions against it. Okay. So this is one example on your laptop. I keep it, I say KISS workflow. It just keep it simple, stupid. And the reason is you instrument Monocle by putting 2 lines of code right here, Monocle _ app trace. And then you set up Monocle telemetries, and that's how it started. And just these 2 lines of code is good enough to basically instrument your applications. I'm gonna do a quick example of a clause queue. You can build it on your own, but we have our templates to build a clause queue with Monocle. Or if you do this in the cloud, there's an MCP version. You can point to the remote MCP and basically ask questions for the trace. What's interesting here is that you can use the trace to do an assert on your flow, and it will pass or fail depends on what the sequence of the tool being called or not called, or basically the output of the agent call, right? So you use number 3 here, the Monocle test tool, to inspect the trace and decide whether it's a fail or a pass test. And basically you can tell Claude hey, if it's fail, go ahead and look at the trace JSON and tell me what happened. And from there, go to the Git history and find out what the code chain was and regenerate the code, right? So you can go into the entire loop circle of this, and eventually you will have a path test and the new code generated. Okay, so what inside a trace JSON? In the trace JSON, you can have something like this. It's very detailed and specific. You can have the workflow names, particular language, the model, the test name, the commit hash. So if something commit in your repo and you have a PR, you actually can get a very precise information of, if something goes wrong, you can pinpoint to a specific commit. And the test assertion message, okay, I have this test for this particular agent, it run through and it failed on this particular tool, and it gives you an output, and that output actually is a pretty good context for you to reuse and regenerate the code, or find out where the bug was. Another example is you can test against the eval. So you can run eval against the input and outputs, and use that as a way to pass and fail. In this example, it's a hallucination or it's a frustration from the user. This text can tell you whether this is a good run or not, and you can do a test against that. Okay. So in the portal, if you go to the portal.co.co, you can see some example that we have with the eval run in the past. And you could execute your eval as well. We have a bunch of eval out of the box. In terms of eval, there's really nothing special, right? It's LLM as a judge. You can create your templates, submit it, and run it. And you can target it run based on a particular criteria. Let's say in a chatbot, user give a thumbs down on some conversation, and that will trigger an eval for that particular conversation. So what the test tool validated on is validate on the agentic response, the tool invocations, the agent delegations, and some of the cost performance indicator. So in this example here, I'm going to show you a quick demo. You book a flight, the user asked to book a flight from San Francisco to Bombay next week, right? And book a hotel in Mumbai on this particular date. And we want to test to make sure that the flight is not supposed to be booked because there's no date. There's a general work say next week, but there's really no date. And it's okay to book the hotel because there actually are dates on this, and we want to make sure that the flight from San Francisco to Bombay has been booked is not a part of the final response. So there's a test type here is negative, and the comparator is similarity. There's a lot of comparator out there. We can use the string comparison to see what the difference between the agent output and the test. So let me do a quick demo here. So this is the example that I showed earlier. In this example, I have a test case here. Okay, so the test case say this is the input, and there's a few criteria. So we have the test case that you can design in the JSON format, and you can do an assertion again a very specific span. And we use this particular test to feed into the LLM to make sure that it regenerates the code. In this case, I'm going to use Claude, and I say use the PyTest to run this test. And if there's an error, call the skill and get more error information and provide code fix, blah blah blah, right? And they actually do that. It run the PyTest again this particular test case, and if there's an error, it's gonna go back and try to fix it. So the demonstration here is that the key in CodeGen on your laptop is actually the test. Once you know what you want, the AI always regenerate the code to make sure that your test pass. So if you have the right test, that will be the golden the secret sauce to do all of this without messing up your code base. So in this example here, it's going through iteration, and let's say, okay, I'm gonna I find the trace evidence that doing this. Booking agent receive blah blah blah, right? Try to fix something. So in this case, fix the prompt because there's some issue with the prompts. Run the test again, fail again. So if you do this several times, it will continue to fix the code until it gets things done. And if I scroll down to the bottom here, eventually it actually figure things out. I fixed the fly agent, the fly booking agent, the hotel booking agents, and update blah blah blah, right? So let me see if I can run this really quick here.
We're not actually booking a flight to Mumbai, right?
We are not. So, yeah, that'd be awesome. So let me see. So you can kind of see the real-time chain here in Claude. The reason I use Claude here because there's a lot of people actually use it to do CodeGen on the laptops. Actually, I pointed to a local model, and then I can use it on an airplane as well. So all you have to do is just repoint it to a different endpoint. So you don't actually have to use like Anthropic and pay them a lot of money for the tokens. And the agent actually pretty awesome. Like the command line pretty awesome. So how many of you actually use Claude on like day-to-day basis? So I use a combination of Cursor and Claude all the time. So for Cursor, if I want to drill down to a very precise piece of code, then I want to have like back and forth iterations. When I have a big requirements, I throw it to crawl, get it run, go have lunch or dinner and come back. So that's basically my pattern. So last time I ran this, it actually took about 5 to 10 minutes. We could come back to this. I'm gonna take any questions so far? No? Okay. So I'm just sharing the best practice, right? So people may argue like there's a tons of different ways to do this. Totally agree. This is one way to do it that I found out it's working well for us, and some customers really like the way we do things, and especially when they have restriction on a network, when things have to be done on a laptop and must carry consistently into the cloud. Okay, so it's complaining about some Vertex AI issue. I'm just gonna leave it here for now. I think it has something to do with like the rate limiting. So that's a little tips and tricks on the test case into your production pipeline. So you can basically do the same thing when you go to production. Same test case being carried into, let's say, GitHub workflow. We have customers who use Jenkins, and they can do the same thing. And you can include Claude now, or GitHub Copilot or Codex as the coding agent in GitHub. And it could go back into your test case and find the outputs as well as all the trace file, and use that as a context with your code base, right? And regenerate it. We have people who actually just use the test case to actually regenerate the PR. So every time something fails, you can go back and regenerate the code and create a PR within the next 30 minutes to an hour or so. And then you end up actually spending more time to go through PR and review it than actually write the code. Okay, so I kind of went through that. So for production use case, it saves people a lot of time to troubleshoot through issue, especially when you have model that nerf overnight. I don't know if you've seen that, but like I use GPT 5.3 recently, and suddenly it just become really stupid, and I have no idea why, right? So there's a lot of scenario where you have to catch those, and you have to assume that it's going to happen, right? So the test will fail in those cases, and it will explain what happened. Okay, so what you get at the end of the day of going through this entire process is that now the chipmunk clean the mess, right? They're actually doing their job. And the reason they do their job is because we actually have the test. The test is looking through the floor, make sure everything is clean, and if you haven't cleaned it, then go ahead and fix it. So just to close it out, I'm actually writing a book. So if anybody interested in collaborating and provide more use case, I'm happy to talk with you. I'm also looking for some reviewers. So you can scan my LinkedIn right there, or send me an email. And here's some links. If you're interested in trying it out, go to portal.okaho.co. Get the demo account. You can get the API key there. I'm not sure you can see this little MCP server thing over here. So I use that to put into Cursor and VS Code. And you can ask questions, again, the trace run. Even things happen way in the past, why it worked before, now it doesn't work. Look it up for me. Those kind of questions. And we hang out in Discord. So if you're chatty on Discord, come join us.